Wanted to thank you all for coming. My name is Joe Fontes. I am a solutions architect with Amazon Web Services, and I'd like to thank CloudBees for having us here. Allowing us to present. I presented at the Jenkins User Conference a couple of years ago, and in spite of that, they've had us back. So thank you guys very much. I appreciate it. Today we're talking about removing undifferentiated heavy lifting with Jenkins. And so what we're really going to be looking at is, give you a little bit of a baseline as far as, how AWS plays with Jenkins, what are some of the ways in which you can use Jenkins on AWS. But this is in no way going to be an all-encompassing presentation on the different ways to integrate Jenkins within AWS or Jenkins with AWS resources. At the end of the day, you're probably going to listen to me talk for about 35 minutes, and that's not even going to cover, 1/3 of the things that, we've seen done with Jenkins on AWS. So we're just going to cover some of the things, a few overviews of some example integrations, and ways that we can enable, cost-effective use of Jenkins on AWS. So I'm part of the Amazon Web Services Partner Network. So what that means is that I work with AWS customers and partners to really drive down their cost of using AWS. The less you spend on AWS, the more resources you're likely to use, right? And so, kind of the baseline is, looking at, why Jenkins, why CI/CD. It's really interesting. A few years ago, way back in history, like 2010, there was no term that I saw for CI/CD. These were the things that we were just doing, as part of our position. So, if you're deploying a Java app, anything like that, you're probably manually compiling, or maybe you got some shell scripts that are running. It's really cool. You can find us down at the AWS booth. We're talking with a lot of Jenkins devs, those that are using CI/CD pipelines within their organization. And so with this type of conference, what you're going to find is that everybody's got like their own shared experiences. So you think of any experience that you've had, like some crazy thing that you've done to mess up a build or something like that, and the person that you're talking to says, yeah, absolutely. Like I was saying, like the time I picked the wrong deployment endpoint, and I deployed like web server code to database servers. And, so anybody here done that? I mean, me neither. I'm not saying that I did. I'm just saying that, if somebody did that, there's a good chance that they would have the same story, but that's not something I would ever do. Looking at why it is that we're using CI/CD now, so we've taken things that we've always done and tried to, automate this process, and so, we've got this concept of the speed of internet, right? And so the speed of internet keeps going up, which is the shortened timeline between when you have conceptualized a feature or a service and when you want to get it in the hands of your customers. When you find a bug, you fix it, and you get that fix pushed out as fast as possible to your application. AWS, obviously, we're releasing services and we're implementing features like crazy. We're a very customer-driven organization. So we take recommendations, requests from the customer, work backwards from the customer to identify these are the services and features that would have the best impact for our customers, that would really drive the best use cases for customers and partners. And this is an accelerated deployment as well. Every couple of years, it seems like we're doubling the number of services and features that we're deploying in order to facilitate the better use of the platform. Looking at what are some of the basics of AWS. So I don't want to spend a whole lot of time as far as what is AWS. When we break it down, there are three foundational components. There's compute, that which is actually performing the computational task. Maybe it's you think of it as like a virtual machine or an instance or a server, whatever it is. This is your computational element. There's storage, so where are you storing all the information? Maybe it's a block device. Maybe it's an object-level storage, and the third is networking. How is everything talking together? And so the real focus of this presentation is surrounding the compute segment. There's 3 ways to purchase compute with AWS. There is on demand, so you just kind of pay as you go. There's reserved instances, so that reserved instances, reserved services, that allow you to say that, for the next year or 2 years or 5 years or whatever it is, I'm probably going to have these 4 servers around as the baseline of my architecture. So I want to get a cheaper price on those 4, but I may need to burst to meet demand. And so you can use something called, you could use the previous instance, which is on demand, or one of the things that we're really pushing for as far as build components, CI/CD pipeline integrations, is to use the spot market. And so spot is unused compute capacity that you can bid on to get the lowest possible price and use for your deployments. If you go through and you do some searches and you say, AWS spot use examples, you're going to find a lot of examples like machine learning, pharmaceutical industry, research, human genome project, that type of thing. And that's because, it's typically thousands upon thousands of instances that you're getting the lowest possible bid on that, you want it to work towards one project, but you may not care if a few of them drop off here and there as the price kind of goes up for each of those instances. And if you think about it, it kind of relates well to the CI/CD and as far as building your application, as far as compilation tasks. These are going to be typically short-lived instances that you're using to compile code to accomplish a task that you're not going to be worried about when they go away after you're done using them. There are tremendous cost savings associated with spot instances, so like 50 to 90% of what you would pay. But kind of the message here is to give it a try. We're going to show you a link that's how to integrate Spot Fleet with Jenkins, but the cost savings there are really a driver for accomplishing what you want in your build environment. So what are, kind of going through, what are the elements of your build environment? So we have our source code versioning system. So last time, when I first started out with CVS, moved to Subversion, we're now in Git, Mercurial. Whatever it looks like, you can integrate Jenkins, you can integrate your CI/CD solution. In the examples today, we're going to be focusing on AWS CodeCommit. It's the AWS Managed Git service. But we're still heavy users of GitHub. I personally, I work with GitHub as a partner. They're a great solution. That's where most of my projects are. But it kind of shows you the pluggable nature of everything that we can do with different solutions and different platforms. We're going to be focusing on how to, what components actually build the code, and then talking about how we can integrate load testing and other deployment scenarios. So we look at, where are we now versus where we want to be? The continuous integration component, whenever I start an organization, I'll find that this is usually where they've either left off or this is where they're kind of stuck at as far as where they want to be in this automated deployment. It's, a next stage to get some unit testing done and get it to the point where we have continuous delivery. But the tough part is getting to the continuous deployment segment, right? So, you've got to have a little bit of faith there. You've got to have such faith in your deployment, in your unit testing, in your metrics, and your performance, in your security testing that you're okay with checking in code and having it go straight to production. So that's always a tough place to get. It's certainly feasible. It's just it takes quite a few resources. And so what does this environment look like on AWS? At the very top here, we have an orchestration solution that we're going to be focusing on Jenkins today. But using these other solutions, such as CodeCommit for source code versioning, we're going to talk about using CodeBuild to actually compile your applications, third-party tooling to actually create unit testing, performance testing, security testing, and then one example of a deployment model, which is code deploy. We're also going to be talking about container deployments as well. So this is an example that was just brought to my attention. It's the implementation of Spot instances with Lyft as an organization and their deployment path. This is a cool example where when you think about I'm deploying Jenkins, and I have my Jenkins orchestration server over here, and I need to do a code build. Maybe your first step is, well, I'll just use that standard Jenkins server, do a code compilation there. Once your organization grows at all, it's going to be too large. It's going to be too large a project in order to do that. Your builds are going to start queuing up. So you have the actual build environments, and maybe you're using Jenkins to orchestrate those different build environments and to farm out jobs, the different servers or instances or whatever it looks like. Lyft was doing something very similar like that, and what they were doing is in order to reduce costs, they were using really small instance sizes for those build farms. So we have something called a T2 micro, which is a really small instance, it's like running something like a Raspberry Pi type of thing. And they would farm out those build jobs to that small instance because it was really cheap. But once that build was done, and it would take so long, but once it was done, that instance was always left running, so they were constantly paying for it. And what they did was they switched to using Spot, so it's actually cheaper than what they were using for that small instance type, but they're getting a much larger instance, the build is completing that much faster, and they're not spending any extra. And so we have, if you Google later, or if you just do a search, we have Amazon EC2 Fleet plugin that's on the Jenkins CI website. And this link here it gives you information about AWS Spot Fleet plugin and module for Jenkins, so that if you install this, it's a community plugin, you can automate the deployment of Spot Fleet. So there's the concept of Spot instances, which are individual instances that complete a task. And then there's the idea of Spot Fleet, which is maybe I need 10 instances in order to complete a job. The AWS Spot market, the prices go up and down. With something like Spot Fleet, you say, I need 10 instances that are roughly this type. Just get them to me somehow. And you instruct AWS to just figure it out. And so that's the module that integrates with Jenkins. So now you have a workload, maybe it's a huge compilation project, you're building multiple Docker containers, whatever it looks like. You just say, I need 10 instances, figure out how it gets done. I want to pay the cheapest price possible. And then that's how you work through it. And these are all short-lived processes, so that once your compilation's done, there's no need to have those hanging around any longer. If you do check it out, there's also a blog post. If you search for Save Costs with EC2 Spot Fleet on the Jenkins website, you'll see the follow the bouncing ball type of instructions on how to get this deployed. And so, it's pretty easy, download the plugin, set up the credentials, AWS access key, secret key, or assume role, configure, and then view status. So we talked about one way to deploy code is via something called code deploy. Another way is with containers. So with AWS, we have a blog post that I didn't put it on here. It's there's a Solano blog post of using AWS Container Repository with container services. Pardon me. To enable a full CI/CD pipeline. That has a Jenkins component as well for orchestration, but you can search that and find that blog post, which is also a follow the bouncing ball. Here's how you implement. But what we're looking at here is you've got some form of code repository. Use Jenkins for your build orchestration. You can farm out the actual building of the containers, packing those containers. Do that with Spot Fleet. You can use something called CodeBuild, which we'll cover in a second. Get those containers all built up, push them up to AWS Container Repository, and then they're managed. Their deployments are all managed with AWS ECS, which is the Elastic Container Service. And so that plugin is also supported by AWS. It's available on the Jenkins community portal. And so that plugs right into your current Jenkins environment. We talked about how to use Spot instances with Jenkins running on AWS. What if farming out those jobs is not something that you want to manage? You don't have to deal with figuring out how Spot Fleet works or figuring out what the market value of Spot is. You just want it to take place and be happy. We have a service called AWS CodeBuild, which integrates directly with Jenkins. And what happens is Jenkins does the entire orchestration of what needs to take place, passes over information to CodeBuild with instructions saying, compile this, do whatever task this is, and then let me know the status and when you're done. Kind of the benefits here is we have a fully managed build service that scales up and down to meet demand, so that if you say that you need 10 instances in order to complete the task, you don't have to remember, oh well, I need to scale back down to maybe 0 instances or 1 or whatever it is that you want to do. You don't have to figure out those details and work with it. You just let CodeBuild take care of the scaling. You pay as you go. You only pay for the services that you utilize, the resources that you utilize. It integrates with other AWS services. It enables the rest of the integration with the CI/CD platform. One of the core components is the security component. At AWS, we have a saying that security is job zero, and so that applies to our implementation of services and our implementation of features. So that's something that we manage. And the process is pretty straightforward, something that you guys are probably pretty used to. You have your source code system. There's some type of trigger to initiate a build instruction. CodeBuild gets a bunch of instructions, gets the source code that needs to be built, and it creates the artifacts that are the output. So maybe it's a jar file, maybe it's a binary, maybe it's a container, whatever it looks like. CodeBuild manages that output and sends it to wherever you want. When we talk about how is AWS CodeBuild extendable, there's current integrations with AWS Code Pipeline. There's integrations with Jenkins. We have a demo that we'll show a little bit later. Also, if you want to stop by the AWS booth, we have the same demo running up where we can talk through some of the details that you guys might miss out on here. As always, this is accessible via the AWS CLI in the same fashion that other services are accessible. And it's also accessible via the API. So you can programmatically set up this build environment, you can programmatically engage with it, and you could build your own plugins and your own modules. When we look at the process of building code, what's involved, we think of things like compilation. If you have a Golang binary, how long does it take in order to compile that? What kind of resources do you need? If you've got a Java jar that you need to pack together and compile, how many required jars are associated with it? How many Maven binaries? What needs to be done in order for you to accomplish this task? And a lot of times you're going to find it's pretty resource intensive. So the question is, do you want to use a small instance type where this may take a half hour in order to accomplish this, or do you want to use a large instance type with something like Spot or CodeBuild to get this done quickly and possibly for the same price or even cheaper? And then there's always there are languages that don't require compilation. So if you're doing like Node.js, if you're doing PHP, you can pack in instructions with CodeBuild that are not related to compilation. You can always pack these into a container, and that would still be a compilation process. Or you can put your unit testing in CodeBuild. If you're using PHP, you want to use PHP unit testing, you could build that right into the instruction set for CodeBuild, have it take care of those tasks so that you don't have to manage that from your Jenkins environment. You could use standard Jenkins just for orchestration. Testing your code. When we talked about how is CodeBuild extendable, it's kind of in the path of the other AWS CI/CD products and also within the Jenkins extendability. What solutions are you using now to test your code? Where is it now in the build environment? So you typically have something like unit testing taking place either in the build server or post-build. What about your security testing? What about your performance testing? Where do those take place? If you want to get to a path that is full CI/CD, straight through to integration, deployment, delivery, you've got to get to a point where all this is automated. If you're doing security testing, you have to feel really confident and really good that after a development phase, your application will scale to meet demand. And so that testing needs to take place. If you want to ensure that it scales up and manages all that load, you have to test it against that level of load and that level of access. Here we have, if we're using AWS CodeBuild with something like Jenkins, we need instructions for CodeBuild. So we need to tell it what to do. So let's say we have a GitHub repository or a standard Git repository. We'll include a file called the build spec.yaml, YML file, which will contain the instructions on what is it that we want to do. And here are the segments. The first one is we're going to set any environmental variables that need to be set. Java Home is one of the first for a Java application. Then there's, within the instance that's going to actually be building this, what is necessary? So what is required in order to build maybe this Java file, or are we installing Golang, or what does it look like? Is it a custom environment? So first thing that we're going to do is pass pass some installation instructions. So here we're installing Maven. For those of you not familiar, it's a orchestration environment to be able to manage Java application compilation. We're saying the next thing to run is going to be the pre-build environment. In this example, we're just saying we're getting ready to build. And then there's the actual build commands, which is the meat and potatoes of this particular example. It's doing the Maven install. For those of you that might be familiar with Maven, your first command is probably going to be like Maven cleanup or something like that. And you don't have to do that with something like CodeBuild because that instance will be reset every time. You're always going to get a new instance, so you're not going to have any old artifacts to clean up prior to do the build or the install. After that, so we've just done our build, and since the next line says post-build, we can assume that that's taking place after the build command, and so that says that this is complete, and then the artifacts are going to be the output. So we see that there's going to be a target jar file, just as if you've built any other jar files, it's in the target directory, so it makes sense, and we're going to use that as our output from the application. And now we talked a little bit about how to integrate Jenkins with Spot. Now we're going to go into how to integrate Jenkins with CodeBuild. We have so we have a Jenkins plugin for AWS CodeBuild, and the idea here is, if you're a developer, how many times have you reinvented the wheel? If you're a DevOps manager, if you're a sysadmin, if you're an SA, whatever it is that you've been responsible for historically, how many times have you rebuilt a build environment? How many times have you customized scripts? And how many times have you gone through this process of, oh, I forgot to check if there was an output file during the last compilation and it pushed a blank file. There's so many gotchas that you probably hit throughout the years, and not to have. And so the idea is, instead of managing those details, this tribal knowledge that you're pushing forward every time you move, it's to hand off some of those responsibilities. So if you have, your Jenkins environment that you're running for, systems orchestration, build orchestration, the idea is you shouldn't have to manage the actual build instances. If you have, let's say, 10 instances or 10 servers or whatever it is that you're doing, do you want to be responsible for managing the software across all 10 of those? It's interesting. Whenever I started a new organization, not Amazon, but anywhere else, whenever I started a new organization, some of the worst patch systems that I tend to find is the CI/CD environment and the monitoring environment. And so for whatever reasons, those are the ones that are always so far behind in patching. And so the idea is, is that something that you really want to manage? Because these are environments that need to be operational. You can't bring down monitoring. And so, let's get out of the business of managing those systems that really could just be short-lived systems, and let's get back into focusing on what is it that we want to develop, what application-specific improvements do we want to drive forward. And here's kind of like here's a high-level overview of the process that takes place. We're going to check, the development team is going to check some kind of code into a source code repository. In the example here, we're using CodeCommit. The Jenkins instance, whether it's via webhook or whether it's doing periodic checking for commits in that repository, will be notified of some type of event where it'll pull the latest iteration of that code. Excuse me. The latest iteration of that code, pass it over to CodeBuild. It'll say, here's my artifact, here is my build environment. It contains a build spec.yaml. So these are the instructions. Do with it what you must. And CodeBuild goes through the process of following the instructions. Maybe it's packing a jar, just like we saw in that previous example. It outputs it to S3 as an artifact and sends logging information about what just occurred over to S3. So we've got all the output of everything that took place during the compilation process and whether or not it was a success and any errors that we saw. once again, kind of a high-level overview. It's, here we'll go back one. Whoops. Sorry. So here we have, let's think of this specific diagram as, here is what orchestration looks like should you use spot instances. For example, and the idea is, to get to that nth build server, you could build this manually. You could integrate with AWS Spot Fleet. You could integrate directly with AWS EC2 or AWS ECS. Those opportunities are always going to be available to you. The question is that something that you want to accomplish? You want to ensure that if you're not running any type of compilation, if you're not running any type of build, how many build servers should you have running? The ideal is 0 because there's no point in that. And so, to help you kind of get to that point as a managed service, AWS CodeBuild, has that pay-as-you-go type of formula so that if you're not running any builds right now, there's really no reason why you should have any of these build servers running it at all. And now we have our demo. I keep telling everybody our demo website, this web application, just masterfully designed from a graphical perspective. Oh, wait, oh, did I write that? Oh, did I create that? Oh, look at that. I didn't realize. All right, hold on, where's play? All right, so we're using this beautiful demo application here. This has been checked into AWS CodeCommit as our source code versioning system. And so what we're looking at is, let's say that this is actually a web app that we're running. What does the process look like to get changes, check them in, and get those pushed to a production environment? Here we have the code build demo. This is the actual build environment. This is what's going to perform those actual build steps. And as it integrates with AWS, with Jenkins on AWS. So we have our, pardon, can't really see. So we have our, below we have our artifact information. So where is it that we're sending this information once it's done with this build process? We have our source code information identified. Where is it that we're receiving information in order to use to build that artifact? The source code information, as we said, will include the build spec YAML. So we'll have those instructions on what should I do in order to proceed. And then, what permissions are necessary. So we have a role that we're going to attach to this process to give it the necessary permissions to, pull the source code in, write the artifact out, and actually push the deployment. Here we have the Jenkins environment working with the CodeBuild plugin. We have our source code. Here we have the source code information. You'll notice that in this example, we are, yes, so in this example, we're not using a webhook specifically. We're using, just a timed 1-minute check of the Git repository to check for any changes that are taking place. We've entered in our AWS access key and secret key as credentials to use to access the service. So this is what we'll use to get access to CodeCommit, for instance, to be able to pull that code, and how we'll interact with the CodeBuild service. We've got some project information and details. And at this point, we've got enough information to be able to pull any updates that are, as soon as a commit is taking place on CodeCommit, we can pull the information over to Jenkins and then push it over to CodeBuild. So here we have the build spec instructions. So this is, what are the steps we take before we build? What are the steps to take during the build? This is a really simple example, just so that, nothing could possibly break during a demo. And so, typically you would have something that's much more resource processor intensive, maybe building a container to deploy to ECR or something like that. So now we need to make a change that we want to push forward. So we're going to change the title and what's shown on that web application, so that we could check that into CodeCommit and have it go through the entire CI/CD process, including unit testing, things like that, to show how it gets sent to production. So we've made a few changes here. Awesome, the CPU, cool CPU. Yeah, so I think they're messing with my amazing web application right now and renaming things. So we've got so standard Git deployment. We're gonna commit the changes, and then we're gonna push the changes up. And then once those are pushed up to CodeCommit, if we were using GitHub, probably just use a standard webhook, which would then kick off the deployment immediately. As we said, the commit here is a periodic check from Jenkins in order to see have there been any commits lately. So we'll wait for this to pick up. And we have it shown here. So it picked up that there was a commit in the source code. And so there's something that, as you're probably familiar with Jenkins, with CI/CD, once we have that commit, Jenkins is going to make some decisions based upon that. What is the destination there? So we've decided with the CodeBuild plugin that the destination is going to be AWS CodeBuild. It's going to send the necessary information along with that build spec and those compilation instructions over to CodeBuild, and then follow those instructions in order to create the artifact. So we've got this is in process. So all those actions that we take in order to do the build, whether it's a Java jar, a C program, a Golang application, as you're compiling, there's a ton of logs that come through, a ton of stuff that you see on standard out. You could see this in both the CodeBuild console as it's happening, as well as via AWS CloudWatch logs, since that's also streamed there. So you can watch this live. Or go back and look at it later. Check out the build last night. Were there any warnings that maybe didn't kick off an error, that type of thing? And as we've seen, we've changed a few of these values. So rad RAM, we've changed the top title, Jenkins demo web app. And this is what we're showing as our production environment. So we've gone through in 3 minutes and made a change in the source code, checked it in, and without any other engagement from staff, this has made it all the way to our quote unquote production environment. Wait a second, I gotta figure out how to get that. There we go. Moving forward, where can you find additional information about the use of Jenkins or CodeBuild or any of the CI/CD platform items? We have the website aws.amazon.com/devops. That'll give you information on all of those services that we discussed. AWS CodeCommit for version control, AWS Code Deploy for managing the deployment, how to integrate containers into your deployment model, using CodeBuild for that compilation process, integrating AWS Code Pipeline as an orchestration endpoint for Jenkins. There's a plugin associated with that as well. So you could say, I want like Jenkins within my on-prem environment or within AWS or whatever it looks like. I want it to hand off certain orchestration tasks over to AWS Code Pipeline. That integrates directly as well. We've got a bunch of white papers, blog posts. Whenever I look at a new AWS service, the first thing I always look at is I download the PDF of the developer guide. And so when you work with the developer guide, it gives you the instructions that maybe you don't see as an end user, things like how do I automate this process? How do I automate this deployment? It gives me a little bit deeper knowledge with a follow the bouncing ball example of how to implement and how to integrate. We also have the AWS DevOps blog. As I mentioned, I've got a blog post there if you want to check it out with AWS, Jenkins, container repository, Elastic Container Service, but there are tons of publications that we update, probably I'd say on a bi-weekly or even weekly basis at times. And this gives you some really cool ideas of how to move forward. The funny part is every time I read something new on any of the blogs, whether it's the DevOps blog or the IoT blog, I read this article and I think, man, I really wish I had that idea, because that is just a really creative way to do an implementation, to do a deployment. It's always, man, I can't believe somebody thought of it before me. But thank you very much. I appreciate it, and we'll do Q&A. Thanks. I think we have a microphone here somewhere. I think. Yeah, that's all right. Oh, so all right. So do we have any questions? All right.
So I guess with the paradigm that you discussed here, where instances can be brought up on demand, the underlying assumption is that you have ability to bootstrap those instances with your entire environment that you need in order to do your build. What tools do you have available here, or what do you recommend for those bootstrapping instances?
Yeah, sure. There's a number of different. So within AWS, as within open source, within technology in general, there's always multiple ways in order to accomplish your goal. So if we're looking at Bootstrap, so let's say for instance that the environment that you want to build against is CentOS with maybe like just Golang and Apache Web Server, and that's it. So one option is you can create the exact image. So create this environment that reflects exactly what you want to do in your Bootstrap, create a snapshot of that, and use that as the environment. So it always boots into that system automatically. That's option one. Option two is, those are probably some simple instructions, maybe a yum install Golang, install a repository, install HTTPD, restart, things like that. There's actually a script area where you can add that to user data. So every time a new instance is deployed, maybe it's the CentOS managed instance or Amazon managed instance, whatever it is, you can just use that with those specific instructions. And that's like the second example. The third would be you can create a container that reflects this environment and use that within Elastic Container Service or Kubernetes or whatever it looks like for you. You can build this into AWS CloudFormation. So I think it's kind of, what's your personal preference? What do you want it to look like? How is it that you want to manage this? There's so many ways to, accomplish each of these goals, and that's kind of the platform of AWS, is being able to say, how are the ecosystem partners using it, and how can we use this to best fit our needs?
I have a question. Are there any limitations what kind of AMI we can use with CodeBuild? Let's say I have a Windows-based AMI which is customized for my build agents. So can CodeBuild use it, or do you need only Linux-based or all Docker images?
So as it stands right now, there's an Ubuntu-based AMI which is used, and where you can really get into your specific AMI, your specific build environment, would be with the using like a Docker container and Docker instance. But at this point, I'm not sure how it would integrate a Windows build environment into CodeBuild. Not to say that we couldn't get creative with it, just off the top of my head, I'm not sure how I would integrate it.
One more question.
Sure.
So when you say Jenkins master will use CodeBuild as a slaves, so do you mean I don't need a slave at all? So is it like when a build is queued, Jenkins master will directly go to the CodeBuild and do, tell it to do the build, or you still need a slave on Jenkins which run your API to, talk to CodeBuild?
So, just as before, it can go multiple different paths. At the very simplest, you don't need to use a slave off of the Jenkins master, but that's really if you have just one build process. What we typically find is when you have a Jenkins environment, how much customization have you put into it, right? Let's say that you've already got 4 steps in your environment, and that's build the code, QA, test, staging, prior to production. You can add an additional step to either add or remove additional steps. So you could say, I'm going to take out the slave step and add AWS CodeBuild over there and keep everything else the same. That's certainly an opportunity. You could say that maybe my slave only packages up a few of the jars, but the main jar file still has to be compiled later. You could say, okay, well, let's add a CodeBuild segment there that does a little bit more of that heavy lifting. It's kind of up to you. It's about providing ecosystem partners and customers with the foundation to build the solutions that best meet their needs.
Hi.
Hey.
If you have like a Jenkins platform and a team of people, maintaining jobs for their department, how do you kind of standardize the specification of resources needed by those jobs? Do you have like some, like with the Fleet plugin, how do you recommend these guys specifying they need a beefier machine or a CPU intensive machine, or the different resource requirements there?
Yeah, no, I always think about when's the last time you've compiled a Linux kernel? It's something that I haven't done for a while. I used to do some Zen development, but I remembered that every time I compiled, I would always send it off to this machine in the corner of the office. I'd start the compilation at noon on a Friday, and I'd be like, all right, on Monday I'll see whether or not it failed or succeeded. Just let it kind of go through. My coworkers kind of make fun of me sometimes because I tend to be a little too cost effective with my resource selection. So I let it spend a couple of days working on it. It's not costing anything. It's on a T2 micro, right? So it comes down once again to a little bit of personal preference, and that's why I like the spot narrative, the spot fleet narrative, because we could say, for the same price that I'm spending for this persistent, kind of slower instance, I could spend for a larger instance, get this build done much faster, free up the resources, and push it on. So when we look at how is it, what is the best practice for identifying what resources are necessary? If we look at something like CodeBuild, it's just managed for you. With something like Spot Fleet, you would say that this family of instances, for instance, I know that my application is going to be, let's say it's Java. I know that it's going to be memory intensive, so I'll probably pick something that's in the R series, which is a very RAM intensive set of resources. I'll select a few different family members off of it. I'll say that this is the baseline operating system that should be run, and then I'll let Spot Fleet manage the rest and say, I'm always probably going to need 5 to 10 of these running in order to complete this task. You figure out the best way to get me that price on that. So yeah, I mean, it's just a little bit about what are your requirements as far as how long this should take and what you want to spend. So I'm still a little bit backwards because I'm still cheap, but it's definitely just as cost effective to get there with Spot now.
Thanks.
Hey.
So, quick question. Looking at your, whatever you called your build file, build spec YAML, it looked very similar to a Jenkins file. So how do you integrate with pipeline or not at all? How does that work?
How does it integrate with Code Pipeline?
Yeah, so I guess say I had a pipeline I wanted to use CodeBuild for certain steps in it. Could I do that? But not for all of it.
So so usually I break up my instruction files. So I would have probably the Jenkins specific YAML file and the CodeBuild specific YAML file, and you can combine them. I'm sorry, you can add the Jenkins build, the CodeBuild build spec later on in the process. So it's I tend to have everything separate. I'm actually not sure if you can combine those into one file, like call out, all right, this is for CodeBuild, this is for Jenkins.
Well, not in one file, but like, say I wanted to kick off a pipeline type job in Jenkins. Could part of that pipeline type job be sending part of its processing out to CodeBuild?
Oh, yeah, yeah. And so that's, we have the CodeBuild plugin that specifically creates, that orchestration environment.
Okay.
So, yeah. So I don't know, did I put up probably the useful thing here would be the link to the actual plugin that does all this, which I don't know off the top of my head. So that was my fault. All right, well, I mean, I'm blind, but I think that's...
All right, so we have, on the master, we configure multiple nodes, and then we have different teams using the nodes. Some of them will use node 1, some will use node 2, but we may have an alias and they just use a group of nodes. Are you saying that this plugin can essentially automatically spin those up on demand, use them, and are they a siloed environment per job, or is it like it's up and running and then multiple jobs can write to the same server?
So just so I didn't quite hear the beginning, are you saying you're using Node.js different versions? Like
No,
one
nodes
versus...
like servers, agents, that slaves
Oh, okay.
for the build environments.
Yeah, so it spins them up on demand. So let's say we take our Maven project example. The second we have that output artifact, those instances are gone. So everything that's compiled, any of the object files that are the intermediate process, they're all gone. And the second you have the next build queue process come across, those new environments are spun up and spun down to accommodate. So that's why you don't have to worry about things like, do we have a bunch of old artifacts? Do we need to do a cleanup? Anything like that?
And you don't have to have this within the job, right? This can be on like the system administrative level, right? Instead of within the job itself that's calling up those different instances?
Yeah, and that's just, it's just the way that it operates automatically. So that's how you manage the scale up and scale down. The second that, you're done building that artifact, there's no reason for those instances in the background to be around any longer.
Yeah, you talked about Spot Fleet and Spot instances earlier in the talk, and given this is Jenkins conference, a lot of us are doing continuous delivery with pipelines that last, potentially hours with many steps. We found our ability to use Spot instances is kind of inversely proportional to the amount that we're doing pipelines that span over longer periods of time. And are you guys thinking at all about how to think about a pattern of like item potency, or where you can run a certain step? Like the example might be you might have a bunch of tests that run, your instance gets taken away, you get a new instance in a new availability zone. I'd like to just run those tests again. It's very disruptive to just keep having like a build just fail because your Spot instance went away. We found that we basically have to use on-demand or reserved instances once we started doing full CD over CI. So we've actually taken a step backwards in that regard. Any thoughts?
Yeah. So it turns out that we got that feedback from others too, right? It was kind of a pain when you're in the middle of working on something and your Spot instance went away, and it's like, oh, that's great. I'm 3 hours into a compilation. Let's start over, right? We're all excited about that. And so that was kind of the thinking behind Spot Fleet. So, you identify, I need this fleet of instances that are going to accomplish this task. I'm always going to have at least, X number, whatever it is that you identify associated with it.
Right, but Spot Fleet doesn't actually prevent any one instance from going away.
Yeah.
And if you get a new one, from Jenkins' perspective, that build slave just went away.
Yeah,
as your
that's true.
entire pipeline is hosted, at least in our experience.
Yeah. So, I guess it comes down to, working with the pricing market to ensure that, you at least have a specific price of that'll, ensure 90th percentile that this instance will still be available, such that, for instance, it'll still be cheaper than RI, it'll still be cheaper than on demand, but you'll have like a 90 to 95th percentile chance that the instance will still be available.
It's good in theory, but if the rationale of spots is that they're cheap and you have to set a high price, typically we'll find spots fluctuate between a very low price and above the on-demand price, and then back to the low price.
Yeah.
At least
Yeah,
in US
absolutely.
West
And
too,
we've received that feedback from customers and partners, we never talk about what we're going to do prior to doing it. Just that we're customer driven. We've received that feedback, and it's something we can definitely understand as a future capability.
Yeah, it seems like something within the Jenkins model, it would be useful to have some sort of concept of what steps in your build process are idempotent. And just, I know that my build step might die because a spot instance goes away, but as long as you can give me a different one, maybe in a different availability zone, I can pick up and resume that build if I can mark certain parts as idempotent or something like that, which I think usually when you're running a test or something like that, it's perfectly safe to just do it again.
Yeah, and you can protect your spot instances, with paying attention to pricing, but there are spikes in those prices. That's where something like CodeBuild kind of shines. It'll just keep with the current instances, and won't scale down until you're done.
I think we found the biggest problem with CodeBuild is, let's say you're running a Java project and you have tons and tons of Maven dependency. Like a problem with Maven is it downloads all of your dependencies in serial, and so we end up adding like minutes and minutes and minutes just for very simple builds, and unless there's like a persistence tier that we
so the option there would be build like a Docker container that contains the necessary baseline. So as soon as you've done the get for all the jars, and they're located in there, then use that as the.
If you have 100 different projects, then you have 100 different sets of dependencies, 100 different Docker containers, and you have to manage all of those and keep them up to date periodically.
That's absolutely true. Yeah, I mean, to be honest, my Maven projects still take forever to compile too. So
yeah, I'm sorry.
Maybe one or two more, and then take the rest out in the hall, maybe?
I'm here all week.
Actually, my question kind of relates to exactly that, which is the warm-up time of CodeBuild is quite slow. So when you, even like the pre-build steps, because you are wiping the image completely, it's having to redo the pre-build steps as well for every build, as opposed to, caching some aspects of that build. If you know that you're going to probably run another build straight after that build, then what we found is, the warm-up time of CodeBuild is just far too long, and we end up doing exactly as you say. We push it out to a Docker file, and even then, it's not caching that image, so it's pulling that image again on that instance, on the CodeBuild instance that's being spun up. So again, if you have like a rather large tool chain, some of our tool chains are the Docker images are gigabytes because for other reasons, and so it's having to pull that image from ECR, each time it's having to do that build. It's not that quick, but it does add, it adds kind of minutes to the builds, and so you're not being able to take advantage of caching the layers with Docker builds as well, because it's pulling the image onto a blank instance that's not got the layers cached as well. So you really kind of basically are, doing a full build, which is not necessarily always a bad thing to do a completely clean build. But if you're doing like a CD to dev, where you just want to push out every single build, every single commit to dev, you're adding like 10 minutes or 8 minutes to a build, and it's just, you want that build to happen in 30 seconds. You want that change to be pushed to dev. As soon as the commit happened, within 15 to 20 seconds, you kind of want to be doing a build, pushing it out. And if you've got Docker and you've got layering set up and you're running it on slaves, that build it's already cached. You're only adding new code to that layer. That takes, a few seconds. Pushing that to a registry, you're only pushing that Delta layer. That takes a few seconds. Pulling that down into the dev environment, that's only a few seconds. So you're talking about like a minute, as opposed to with CodeBuild, that process potentially taking a minimum of probably 5 or 6 minutes per build, no matter what the build's really doing. That's sort of the experience we've had so far.
Yeah, yeah, absolutely understandable. You know, one of the things I will say is that when we look at other service initial offerings, something like the Elastic Load Balancer, for instance, there used to be this idea of pre-warm and warm-up times, and you know what we found is you know it used to take a little too long, you know, to be comfortable with, and so we, you know, it's now in a state of pre-warm, so that you know you're able to scale up much faster, you're able to deploy much faster. The same thing with you know the implementation of Lambda, things like that. So while I have no knowledge of anything like that taking place, I don't think it would be outside the realm.
Yeah, that's kind of what we were thinking, is being able to say, hey, I've got these. Here's the base steps that I want to have. I want to have capacity of that ready to go. And in a lot of cases, you'd be willing to pay for that, right? You'd be willing to pay, you know, some percentage of that to say, okay, that means I'm going to get an instant build. Some cacheability of that. Also the ability to customize some of that to say, actually, here's a base AMI for CodeBuild, right?
Yeah.
Use this AMI. It's already got everything. All the dependencies are already met.
So, you know, one of the things I will point out is we are a customer-driven organization, so feedback like that is what does help us, you know, improve services and identify, you know, when I showed the first graphic of, you know, these are the features and services that have been implemented, that's the type of feature that would make that list, so, you know, as a deployment. So, yeah, I mean, yeah, we love feedback like that. Yeah. Thank you. All right, well, thank you very much, guys. I appreciate it. Thanks.